So in this situation, we have a body moving along a straight line. It has a mass of 3 kilograms, and it has a kinetic energy of 24 joules. The motion is opposed by a net force of 4 newtons, so there is a net force of minus 4 newtons, because it's the opposite direction. And it's going to come to a rest, so V will equal 0 after a distance of, and that's going to be delta x. So we are looking for a distance. Well, our first step in solving any distance problem is to start out with our average velocity. Average velocity is delta x over delta t. So delta x is average velocity times the time. And we also know the average velocity is the final plus the initial over 2. Now, we know the final is going to be at rest, so we know that V bar is 0 plus V0 over 2. So average velocity is V0 over 2. So we don't know the average velocity, we don't know the initial velocity, we don't know the time, and we don't know the average velocity. So we have to go about finding that some other way. Now we have the kinetic energy. So let's break apart the kinetic energy. Is 1/2 mv squared. And we know that there's 24 joules. And there is a mass of 3 kilograms. So 48 over 3 is v squared. V squared is 16, and V then is 4. So the average velocity is 4 over 2, or 2 meters per second. So delta x is 2 meters per second times the amount of time it takes to do this. Now, the information we haven't used yet is this force. So we can now go and use our four-way equivalence, which is I is F net delta T is delta P is M delta V. Now we have masses and velocities, and we have forces, and we don't have the time. So immediately now we see that this can allow us to find the change in time. So we have a net force of 4, and that's going to be minus 4, times the change in time is the mass, which we know is 3, and the change in velocity, it goes from plus 4 to 0, so the change in velocity is 4. So delta T is 3 times 4 divided by minus 4. So the change in time then is 3 seconds. Now, of course, we can't have negative time. So we have 3 seconds. So 2 times 3 seconds is a displacement of 6 meters. Choice B. Now, I just want to step back and talk about the larger process here. How we began this was we made sense of the quantities here. We even specified some things like rest is a velocity of 0 and distance is delta x, and we've got a mass and our kinetic energy. And since we're looking for a distance delta x, we started out with, this is a kinematics question, the displacement. So we started with our average velocity formulas and did what we could, but we realized that wasn't enough. Then we went to something else we knew, the kinetic energy. And the kinetic energy allowed us to find the velocity. And once we knew the velocity, we still needed the time. The velocity allowed us to get the average velocity, and so we still needed the time to find the displacement. So what we were doing here is being systematic, looking at every aspect of the problem. And every time we found out something new, we would go back and look anew at what we had started with. And that's why we start with the average velocity to begin with. So we started out with the kinematics, and then we went to the energy. And based on what we were needing, we went to the momentum. And the momentum, the energy brought us back to kinematics, and the momentum brought us back to kinematics, and we just kept going back to that average velocity. We don't have to know how to do a problem when we start. What we need to know is what are the steps I should take to solve every problem.